Hello everybody, my name is Derek Delacruz, and this is my work for the Chapter 21 project for the AP Physics curriculum. Let's get right into it. The objective of this project was to explain questions 86 through 90 in the problem section of Chapter 21. The problem we presented with is, the charge center and the ground function act as a charge capacitor, with a potential difference of approximately 4 times 10 to the 8th volts. The large electric field between these two electrodes may ionize the air, leading to a conducting path between the cloud and the ground. Charges will flow along this conducting path, causing the discharge of the capacitor, a lightning strike. Both charges are 25 coulombs, but the charge in the sky is negative and the charge on the ground is positive. The distance between them is 10 kilometers, and the charge in the sky is 1 kilometer in diameter. Problem number 86 states, what is the approximate magnitude of the electric field between the charge center and the ground? An equation we can use for this is E equals V divided by D. This is electric field equals voltage divided by distance. We know the voltage is 4 times 10 to the 8th volts, which was mentioned in the context of the problem, and the distance is 10 kilometers, which is also 10,000 meters. Dividing those, we get 4 times 10 to the 4th volts, meaning that the answer is A for 86. Question 87 asks, which of the curves sketched in figure P21.87 best approximates the shape of an equipotential drawn halfway between the charge center and the ground? We know that these lines are always perpendicular to electric fields, meaning that B is incorrect and C is incorrect. Comparing A and D with the diagram, we see that the line has to be pointing downwards in order to work with the electric field lines, meaning that our answer is A for question 87. Question 88 asks, what is the approximate capacitance of the charge center, which is positive, on the ground system? We can use the equation Q equals C times V, and this is charge equals capacitance times voltage. We write in that we can get capacitance equals charge divided by voltage. We know the charge is 25 coulombs, and the voltage is 4 times 10 to the 8th volts. Divide 25 coulombs by 4 times 10 to the 8th volts, we get capacitance equals 6 times 10 to the negative 8th farads. The answer is A for 88. Question 89 asks, if 12.5 coulombs of charge is transferred from the cloud to the ground in a lightning strike, what fraction of the stored energy is dissipated? We can use the equation U equals half CV squared. Now what this means is, the electric potential equals 1/2 times the capacitance times the voltage squared. Now, this 1/2 means that 50% is already lost, and if 12.5% is transferred, that is 50% of 25 coulombs, which is the charge of the actual system, meaning that it's already 50% drop, then the equation drops that amount by 50% again, meaning that in the end, 6.25 coulombs are sent out. This is a drop from 25 coulombs to 6.25 coulombs, so this is a 75% drop, meaning that the answer is D for question 89. The last question, question 90, asks, if the cloud transfers all of its charge to the ground via several rapid lightning flashes lasting a total of 1 second, what is the average power? So one equation we can use for this is U equals 1/2 times Q times V. Q is charge and V is voltage. We know that Q is 25 coulombs and V is 4 times 10 to the 8th volts. Multiplying that out, we get U equals 5 times 10 to the 9th joules. We know that power is energy over time, and time is 1 second, meaning that our power is just 5 times 10 to the 9th watts, which is equal to 5 gigawatts. The answer is C for question 90. Thanks for watching.